So, a very good morning to everyone here from Hexagon and Leonardo Helicopters. Thanks a lot for Lisa to join me today to have an excellent presentation on the determination of composite allowables, what has been spoken over the last few days here at JEC, on how we can make the circular economy up and running for the new developments and to reduce the downtime, to scale it up to level that we can put it in the serial production as soon as possible, and to manage the resources in an efficient way that you don't spend too much time, too much energy, too much resources onto the qualification of the composite materials, which is going to be a drivetrain for the next level of net zero emissions, which was being shown by the colleagues previously from Airbus, from Leonardo, and also from the European Union, that they are targeting net zero emission by 2050. So the presentation is structured in such a way that I will be presenting the theoretical part, the solution, what we offer from the house of Hexagon, that addresses the solution that comes with the different levels in the value chain in the composite qualification. And then Lisa will be presenting to you the theoretical, not the theoretical, the experimental part, what has been done at Leonardo Helicopters with the solutions, what we have proposed before. So I put the slide just before the start of the presentation because I was going around through the different booths here and then met very interesting people, and there's always a confusion with the name Hexagon. So Hexagon, I'm not from the part of the company which produces any of the carbon fiber tanks for the hydrogen fuel cells or for the hydrogen supply chain. I'm from a company where we produce the sensors and the software for that. So our goal is ideally to make this complete process chain with the parts and manufactured parts from the design up until the qualification of the part, and to make the data that is available existing from the real world and from the virtual world, and to combine the data together and make an autonomous system that works by itself, and then that provides more value to the existing legacy systems what you already have in board. Saying that, I move a little bit more deeper on where I come from. So I belong to the division of Hexagon Manufacturing Intelligence, where we deal everything that is related to the manufacturing. So it starts with the design or the concept that you want to have to be produced in the final part, and then it starts with the design and engineering that you iterate with the design and you do simulations, and then you select the proper material for your design, and then you make the production, and then you do the quality inspection, and then you finally qualify the parts. So everything touches with the material, and of course composites, where we are speaking a lot on these days, how we can efficient the manufacturing of the composites, and then how we can effectively use the best product for the best, or let's say the best material for the best product. So diving one step deeper, I'm the business development manager for the digitalization of materials. So I'm more working on the digital transformation in the material science industry. So we focus on 5 different pillars. So I will be providing more information on the material data management. That is a solution that we offer to not only to the composite industry, but to the manufacturing industry, where you can completely track and trace all the different systems or different stakeholders those are involved in transforming and exchanging the material data at different levels of interaction. And then I will be starting with something called Digital Materials Laboratory, for which Lisa will be also providing the data, what has been done at Leonardo Helicopters. So which makes the virtual qualification of the composite material for any of the specific application much easier, with reducing the number of the physical tests that you need to do the complete qualification. So which means it increases the speed with which, or it accelerates the speed with which you can qualify your composite material with reduced costs and reduced efforts. And then there are 3 additional pillars which are worthwhile to mention. So manufacturing simulation, this is also a part that we are putting more focus in the recent days, that combining the manufacturing uncertainties into the earlier stage as possible during the design itself, to foresee what uncertainties that you will be having when you are manufacturing a part, and then to eliminate those hurdles to make you up and running and to produce your part as quick as possible to meet the market needs and also to meet the regulation deadlines. And one more thing which is quite interesting would be the multi-scale simulations. So which means we provide simulation software. Those are making you to not only focusing on the macro scale level or the part level, you can also go deeper and deeper, and then you can see how your microstructure of your part looks like and how you can characterize the composite in a better way that you get the maximum out of the properties or the maximum out of the composite material itself. Not just the materials, you can also go with the microscopic approach to the part level, and then you can also characterize your part as accurate as possible. Saying that, I would like to introduce the 2 solutions which I was mentioning before. So let me start with the digital material laboratory. So here you see the first thing is like the objective of this solution is to make a digital twin of your material. So irrespective of what material system we are speaking about, but here I would like to focus on the composite material. For the fiber reinforced material, we make exact digital twin. So you combine the real world data, and then you can take the virtual data, and then you put it in a way that you leverage those data interaction, and then you can make the maximum out of both of them. And then in a literal sense, you have exact digital twin with which you can foresee each and every aspect of your production, each and every aspect of your part performance, and you can incorporate it as early as possible in the design phase. So saying that, if you have the effective digital twin, then it makes the life easier for the material selection. So you select a material that best suits for the application, best suits for the regulation. And then, as I mentioned before, so we also connect that real world with the virtual world in this scenario. And all the value additions, what you can get is like you can accelerate the material innovation. So if you have the digital twin, there is no need that you need to do all the extensive tests that you needed for the qualification, and then you can go ahead with the digital twins. And here you can reduce the development time and cost, and then you can increase the productivity as mentioned before. Then the key points which I want to highlight in this aspect or in this solution is the key value propositions what we provide from the House of Hexagon. So with this digital laboratory, we help you to define the whole DOE with the test matrix definition, what you need for the development of the material and the qualification of the material. And then we set up a workflow that suits for your expected qualification, for which kind of test you need to do and which virtualization you need to do and which physical tests you need to take into account. And then we also provide the possibility to analyze and screen the data, what you get from both the physical and the real world. And then you can explore and process all the data, what you get from your experimental and then the virtual testing. So as I mentioned before, so we start here strongly with the coupon level testing. So we just characterize or put more focus on qualifying the material as such before it goes to any application, because that's the foundation of each and every product, the material that goes in. So we put more effort and we put more capabilities that accelerate the testing campaigns and provide you the better insights which you need for the whole development phase. So if you set that foundation stone correct, then you can build up your product, and then you can go to the subcomponent, and then you can finally be successful in having a component that matches the requirement in all the aspects. Then saying that, we have the digital twin ready for the material. So these are the existing standard failure criteria that we have implemented based on the ASTM standards, still heavily weighted with the ASTM standards, but these are readily available, which means like you have fine opportunity to tweak in and to also match for your local, let's say, the standards that each and every single OEM or the component manufacturer follows. And you can also tweak it to the local regulatory standards, and you can play with that. And the potential is endless. A little bit more on the information. So as I mentioned before, so you can run a complete variability and statistics with the tool what we provide, and it doesn't stop there. So you can include the parameters, and then you can run a parametric study with material parameters, with manufacturing parameters, and the creativity is the limit here. So you include as many parameters as possible from different dimensions, from experience, from the legacy information what you have. And then we have the post-processing tools, like you can have this carpet plot, so you can analyze the influence of one parameter with respect to the other parameter, how it's going to influence the performance of the part. And what we are putting more effort is the effect of defects. So we do a complete virtual setup to include the different defects that could be coming in from the manufacturing process, and then we consider that as early as possible in the material development phase itself. So then the next solution which I want to just touch in before I give it to Lisa to present the test results is MaterialCenter. This is a clear end-to-end material lifecycle data management tool. So it provides the opportunity to connect the different stakeholders. So you can interact with your material supplier, and then you can get the data from your material supplier. It could be the testing lab, or it could be also the other sub-suppliers of the material, getting different materials from different suppliers for parts. So you can connect it to everything in a single system, and then you can allow the system to interact with the different stakeholders, which means throughout the complete life cycle of the part, starting from the supplier manufacturing the material and then qualifying the material in-house or external. Then you have your designers and the part responsible who are working on the part can interact without any human interaction. So which means like with the same system, it's a central source, and then you have only one point of contact, and then you can access the information without being lost or without being anyhow let's say, lost between the communication. And then you can include the manufacturing data, you can include the compliance data, you can include the sustainability data, and you have everything put in there, and then everyone have the same access to the data. And we also have different possibilities that will be explained later from Lisa, how effectively you can use that system to compare the experimental and the virtual data. Then this database also provides you to the connection to the existing databases in the market, the commercial data banks. You can connect with the commercial data banks, you can connect with your legacy data system, and then you can make use of that and then get profited in the maximum possible extent. And being said, we put also more weightage on the AI and ML to virtually generate the data. So just to going through, as if you see a test matrix like this, and then all these gray zones are the data what you have, and then the white zones are the data which are missing. What I would like to say is it's not purely the data science-based approach. It's completely based on data science plus material, the physical characteristics, the physical phenomenon. We will put that physical phenomena inside, and then we combine both of them, and then what we do is it's called smart data generation, and this is the new product which we have launched last month or the month before in Feb. It is called Nexus. I can provide you more insights on that later on. And right now, considering the time that's being running out, I will hand over to Lisa. And
thank you, Bala, for these Hexagon products overview. And I am Lisa Volpi, and I'm part of the team of non-metallic material laboratory in Leonardo Helicopters in Italy. And let's get even more specific with a test case using Digimat virtual allowables and MaterialCenter. Now, a brief overview of our company. And Leonardo Helicopters is the leader in the civil market, and our portfolio of commercial helicopters is ideally designed to a full range mission through the latest technology and high safety standards. And now, in the following 4 slides, I'm going to show a real case study performed with the aid of Digimat virtual allowables and MaterialCenter. And in particular, we are going to see an open-all test campaign. Well, this project is involved in the greater Leonardo's digital transformation project, in particular, the digital transformation in material laboratory. The reported case study presents a comparison between a first scenario with three real batch of an OHT test campaign, each one with 5 coupons, compared with the second scenario with a virtual test campaign and experimental test. That is to say, we are going to show an hybrid test campaign with 2 virtual batches, each one with 5 coupons and 1 experimental batch. And the main aim of this project is to extend this project flow to a complete material qualification in order to reduce the experimental test and, as a result, reducing costs. And we are going to see these, in these slides the graphic user interface of Digimat virtual allowables and results. Here, the first part, where the user has to add the characteristics of the material. And for us, the material is a pre-preg carbon fiber. And then the user can add the layup of the coupon. And then it's possible to choose the test that we are going to simulate, and then the environments. In the second part, the user had to choose the variability of the test campaign. In this case, we are going to simulate totally virtual test campaign of 3 batch, each one with 1 panel and each one with 5 coupons. Then we have to set the PHA analysis parameters, and for these OHT test, we choose a custom mesh with 100 elements in length, 14 width, and 60 in notched width. Here are the results, the digital results from Digimat virtual allowables. And on the left side, we have the bar chart of the 15 coupons and the output, the virtual output of mean laminate strength, the B basis, the A basis, the standard deviation, and COV. And on the right part, we have all the stress strain curves of the 15 coupons overlaid. And okay, this is the fully digital test campaign with 3 batch, with 5 coupon each batch. Then, this is a comparison between the failure mode of the experimental batch. As we can see, the failure is from the 45 degree from the hole. And on the right side, we have the PHA analysis output in terms of damage components. And as we can see, we had reached the same failure mode in the experimental and in virtual analysis. Okay, let's get with the data analysis of this test campaign. On the left side, we can appreciate the experimental data with mean strength, laminate strength, B basis, A basis. And on the right side, we have the hybrid test campaign with 2 virtual batches and 1 experimental batch. As we can see in this slide, we reach very similar results from the fully experimental test campaign and in the hybrid test campaign, not only in terms of OHT laminate strength, but also in terms of A basis, B basis, and COV. And this analysis could be made using a common spreadsheet, but we want to reach the material digitalization, and we use for this another Hexagon product, MaterialCenter. And we can see in the upper part of the slides the Leonardo interface of MaterialCenter. And we can see on the left side the bar chart comparison of 5 experimental coupons for 1 batch and 2 virtual batches with 5 coupons each one. And the same analysis that we have made with a spreadsheet, it could be made with the aid of MaterialCenter. And as we can see, we can calculate the mean OHT laminate strength, the B basis, and the A basis. And on the right side, we have a very powerful diagram, because in this diagram we have 5 stress strain curves from experimental analysis and 10 stress strain curves from the virtual analysis. And as we can see, the virtual stress strain curve fit great the experimental one. Okay. Let's get with the pros of this project flow. As we have seen in the previous slide, we can reach the same failure mode of the experimental test. Also, we had the same result, a very similar result to compare from experimental batch to the hybrid approach. And we have also all the stress strain curve that fits the experimental one. And for this, the pros are obviously a faster material characterization with a reduction of the cost. And in MaterialCenter, we have a smarter approach to the data analysis. And we can have a common database of virtual analysis and experimental tests using also MaterialCenter. And we have next steps for this project, and we want to extend this approach to a complete material characterization. And as we can see in the diagram, we can reach a reduction of the 60% of number of experimental coupons. And also, we want to introduce the analysis of defects in Digimat-VA, that is to say that we want to simulate coupons with defects, and we want to compare with experimental coupons with defects. And also, we can use the Digimat-VA database to add the characteristics of the prepreg in the wet condition at lamina level, and we can simulate the laminate properties using Digimat-VA. Okay, thank you. And this is a very powerful project for me. I think that this hybrid approach would be a very interesting thing to reach the digital transformation in material science. Thank you.
Thank you. Thanks a lot, Lisa. So I think we still have 48 seconds. So if you have any questions, we are more than happy to answer. Oh, okay, then not anymore. So we will be around here. So for any questions, we are more than happy to answer you. Thanks a lot. Have a nice JSC. Bye.